Hello and welcome back. Today we're looking at another puzzle. This one looks fun. I saw Kraken Cryptic uploaded a video where they solved this one. It was marked as approachable on there. Haven't seen it on Logic Masters Germany. Tried to have a quick look for it to see what it was rated there, but nonetheless, it's got a fun rule set. Haven't seen the solve or anything yet, so we'll see later on what that looks like. The rules are as follows. Regular Sudoku rules apply, which is great. You have crop key dots, the black and white dots indicating a 1 to 2 ratio and consecutive digits. You've got German whisper lines, which are the green lines. I think we can see one there in the corner, which means that numbers along a German whisper line have to differ by at least 5. That's adjacent digits differ by at least 5. And then we have the wobbly whispers, which are these yellow lines everywhere. And numbers along a wobbly whisper line, a yellow line that are adjacent, have to differ by exactly 3 or 4. Exactly 3 or 4. And digits may not repeat on a line, even if Sudoku rules allow it to. Okay, this looks like it should be fun. Let's give it a go. Right, okay. Nice, okay. I'm seeing a couple of fun structures, I think. This is maybe the thing which jumps out to me first. And I think it has to be 5, but let me just think about that for a second. Yes, okay, so let's suppose for a second that it was 4. Then you'd have to have 4 numbers which differ by exactly 3 or 4 from 4. So you could have 8, you could have 7, you could have 1, but then you'd have to have 0. No bueno. So the only way you get 4 unique numbers is if you've got 5 there. So 5, and we've got 1, 2, 8, and 9, I believe. Cool. All right. Um, with that being said, these are also interesting, I think, because I think these numbers have to differ by 1. That might not be true. Either these or these have to differ by 1. So you might have something like, I guess, 4, 1, 5. Oh, pardon. No, we're okay. I was hearing noises. 4, 1, 5, 8, 4, or 4, 1, 5. Yeah, sure. So there's going to be some kind of close relationship there anyway. These dots are always interesting. Can't have a 5 on them. Can't have a 7 on them. So it's 1, 2, 3, 4, 6, 8. Same thing goes here. This one's slightly interesting. I think you can have 4, 5, or 6, but you cannot have 3 or less or 7 or more. So I think that's got to be 4, 5, 6. Oh, of course you can't have the 5. You've put a 5 in. Silly me. Same thing down here. Means we've got a 4, 6 pair. That being on a Kropki dot means this is either a 2, a 3, or an 8. Which means that this will either be a a 1, 2, 3, 4, 7, or 9. But it cannot be a 4. So it can still be... It cannot be a 4, it cannot be a 1 or a 2 or a 9 actually. So it can't be a 1, can't be a 2. 1, 2, 8 or 9 are gone because of a quadruple. Cannot be a 1, it cannot be a 2. It can be a 3. It cannot be a 4 because of a pair. It can be a 7. Cannot be a 9. I think that's right. Alright. Interesting. How about down here? I guess this doesn't really matter. You could have just about anything. I don't think it's very constrained. German whisper lines, we can't have a 5 on them. And you can't have a 5 on them either. So 5 lives somewhere up there. And this seems like we're at a little bit of a wall. So if this is 4, then you'd have to have 1, 7 and 8. 1, 7 and 8. And if it was a 6, you'd have to have 9, 2 and 3. 1, 7, 8 and 2, 3, 9. Interesting. I don't know that I can do any elimination of it. 2, 3, 9. If this was 2, 3, 9. Oh, this might be interesting. If that was 6. And we've got 2, 3 and 9 here. 2, 3, 9. 2, 3, 9. Then this cannot be 3, 6. This cannot contain a 2, so it cannot be 1, 2. It cannot be 2, 4. It can be 4, 8 though. And if it were 4, 8, it would have to be 8 there and 4 down there. That's annoying. Okay. Ooh, but maybe there's something to this. Okay, let's... Now suppose that this was a 4. Pardon. This was 1, 7, 9, I think we said. No, 1, 7, 8 we said. One, 7 and 8. So, we cannot have 1, 2. We cannot have 2, 4, because the 4 is placed. We cannot have 4, 8. We can have 3, 6 on paper, but since this is a 4, this will in turn be a 6, and because we've got the double here, this would be a 3. So this cell cannot be 3 or 6, meaning you cannot have 3, 6 either, and there's nothing left. 1, 2, 2, 4, 4, 8, 3, 6. There's nothing left to go there. So this cannot be a 4. This has to be 6, and we have to be in the first configuration, which is awesome. That's really good. Which means we've got 2, 3, 9. And that left us with 4, 8, didn't it, I think? So not 1, 2, not 2, 4. Yes, 4, 8. This will be 8. This will be 4. That will be 4. Oh, okay, that will have to be 2. That'll have to be 3. And that's lovely. We've done quite a lot of work there, eliminating options. This cannot be a 9 now. That has to be a 7. That doesn't do anything for us yet, but no doubt it will. We can put in our options here. I think we've got 1, 7, and 8 as our options. So this one can be a 1 or a 7, but not an 8. This one can be a 1 or an 8, but not a 7. This one can be all 3. Okay, 2, 3 is a pair here. Now we're left with 1, 5. 1, 5. You cannot have 5 on the Kropki dot, the black dot anyway. So that's 1, forcing a 2. That is 5. This forces it to be a 3 because you cannot have another 1. This is all becoming very lovely. 5. This is either going to be a 4 or a 6. Both are useful. If it were a 6, you'd have a 3 there. Oh, and we cannot have it. We've already decided for ourselves that it's not a 6. I should have seen that, totally. So we've got 4, you cannot have a 2, this has to be an 8. 4. We're strapped for options here, this has to be either 1 or 7 now. 1 or 7. If it were a 1, this would have to be a 4 or a 5. It cannot be a 4 again, of course, so it would have to be a 5. If it were a 7, then we would have to have a 4 or a 3. It cannot be a 4 for the same reason, so it's a 3 or a 5. Very interesting. This is working out to be a really lovely puzzle. I'm going to remove the 1s, which are no longer an option here, and that resolves a number there, which is stunning. We've got a 1-7 pair, resolves even more here now. Means you've got a 2-9 pair, which actually gives us the 1-8 pair in this column and resolves. Oh, this is just lovely, isn't it? Wow. All works. Isn't it just lovely when it all works? That's great. Okay, what are we missing? 7 in the center, and we should have one more pair between them, and it's going to be a 4 and a 6, which we can resolve. And the center root has really come to life. Boxes 2, 5, and 8. I'm not sure how much more we can restrict these two. 3 can go anywhere. 5 is stuck on this side. 6 is also stuck on this side. Okay, then we scrap what I just said. We can certainly say useful things, because that's 5 and 6, and that makes this a 3 and 9 pair, which is lovely. Cool. I have to say, this is very satisfying. Okay, what are we missing from row 9? We are missing 7 and 6. 6, 7. This has to be at least 5 apart, so 5 or more apart. In the case of a 7, that gives us the options of 1 and 2. We cannot have a 2 because of a 2-3 pair, so it is a 1. That doesn't eliminate 7 because it's 5 or greater. So both of those are still valid, but that does fix up this for us. Oh, and it all comes together. Okay, this is now a 9 because 6, 7, and 8 are all taken. And this is interesting because 3 and 6 is no longer an option, 1 and 2 is no longer an option, but 2 and 4 and 4 and 8 are both options. 2 and 4 and 4 and 8 are both options. Okay, 2 cannot go there, so this is a 4 or an 8. And this, I believe, can be any of the options. Yes, 2, 4, 8. Alright. 4 and 8. You imagine, there must be some restrictions on the yellows, but I don't think they're going to be strong enough yet to get an awful lot out of. I mean, if that was a 4, this couldn't go down to a 1. If that was an 8, this couldn't go down to a 6. Okay, there's enough restriction here. I changed my mind yet again. This is really magically done. Okay, if you had a 4, you have to go up to 7 or 8. You'll see neither of those work. You cannot have 1, 7, or 8. It's lovely, so that has to be an 8. You have to have an 8 there, meaning you have to have a 4 here. Meaning that can't go to a 4. You have to have 5. At which point you either have to drop down to a 2 or a 1, cannot be a 1 for sure, or go back up to an 8 or a 9. It cannot be an 8, and it cannot be a 9. So, I believe it has to be a 2. Then you've got 3 and 7 left there in the column, and I don't know what to say at this point. I keep thinking there's no point looking in this area. There's not going to be anything to find, and I keep being proven wrong. So I suppose we can have a little look. This is either going to be 1, 7, or 8. It cannot be a 7 because it's in the box. It cannot be an 8, so yeah, it's a 1. That makes that forced to be a 5 because 4 is taken. And we resolve the hardship in the center. Nice. Okay, the 3-9 pair in the column should have already resolved that to be 2 and 3 in that order, so it's my bad for not doing that earlier. And we are missing 5 and 2, which we can place. And I hope my general Sudoku speed picks up a little bit. Oh, pardon. That's poor. I hope my general Sudoku speed picks up a little bit in the coming weeks. I know that should probably be corner cased, but forgive me this time. I'm going to just go with it. Okay. Right. I guess this should then be plausible. We've got 3 numbers. Which of them are 3 or 4 apart? We should be able to tell in a number of cases. You've got 4, 8, and 9 missing, which means it's got to be 4 and 8 there, and 9 over here, right? You think? I think so. 4, 8, and 9 missing, so 4 and 8 in some order there. And what is missing over here? 1, 5, and 6. So again, 1 and 5 in some order, and then that'll have to be 6. Meaning we cannot have 3, 6 there, so we've got 1, 5, 1, 5, and 4, 8, 4, 8. Now, 4 cannot go next to 5. 8 cannot go next to 1. So I think my comment of what I said earlier about opposites needing to be at least 1 apart on one of the sides is true. But we don't know which side. So either this is 4, 5 or this is 4, 5. So once we do find one, we can resolve both pairs. Which is interesting to see what the utility of that was. So, right. Now this. You can't have 3, 6. You can't have... No, you can't have a 4 or an 8, a 3 or a 6 here. Or a 1. This could only be a 2. And that it has to be. Then you've got 1 or 4 here. And both are allowed. Which would leave you with 2, 3, 5. But you can't have a 3. You can't have a 2. It has to be a 5. Can't have 2 or 3 for Sudoku reasons. Meaning that this does get resolved. And again, you just get this magical unraveling, which we love so very much. Everything seems to start working. And at this point now we can also continue to unravel, like we said earlier, these elements. Is this going to have to be the same thing with 4 and 5? 4, 5, 1, 8. I suppose it could be, well, it can't have a 4, it's going to have to be 5, 6, 2, 9. Should I just be brave and write it in? I think that's a 2, I think that's a 6, I think that's a 9. It can't be a 1 because of this. There. It can't be a 8. It can't be a... Oh, it can be a 9, so it's 2 or 9 in some order. 2 and 9. That can't be the 2 there, so that has to be the 2. That has to be a 9. And 6. Okay. The intuition was right. I'm glad I went through and convinced myself a little bit more logically before going gung-ho. Okay. The central boxes are complete, as are the bottom boxes. This should surely be able to fill itself in at this point. No, we can't say yet what the resolution of that is, but it's 103. This is interesting. You can't have 1, 2, 3 in any of these. So this is 4, 5, 6, 7, 8, 9 with no 7. 8, 9. Okay. Not quite convinced. I was wondering whether we could discount 8 and 9 being both in here, but we can't. If 9 is there... No, we can. If 9 is in there, it has to be in the middle. Then you cannot possibly have 8 also. So you cannot have both 8 and 9. 4, by Sudoku rules, is placed there. So this is 7 or 8. It cannot be 8. It is... And it can't be 1. And now you've got 5 or 3. By Sudoku rules, it's got to be 5. It's lovely. Okay, those are actually deceptively powerful. I think that's very interesting. What a cool invention. Okay, we've got 6, 9 down here. And 6, 7 up here. Ooh, 6, 7. One for the younger audiences. Ooh, I keep getting my keyboard wrong. My keyboard is placed behind my microphone, and I don't really have a sensible way to get around that. But it means that I can't see my keyboard, and I depend on touch typing, which is clearly something I'm not very skilled at. I can only hope that in time that improves. I have tried to set up the number pad, but I don't seem to be able to get used to it. I keep trying to revert to finding the keys the old-fashioned way, but I might have to get with the times. These are all write-ins. So we've got 1, we've got 3, and we've got 9. As such, and this should just be the final formalities of the exercise. This yellow one must be here to do something now. Interesting. There must be a purpose to this yellow line. It must be to get rid of some uniqueness problem, maybe with a 6, 9. But 6 is in the top, 9 is in the middle. Okay, let's see. Well, we can actually resolve that because it's 6 and 4. And we've already resolved this. 9 could have been on there, but it's not. So now it has to be 2 or 3. And it'll have to be 3. And that'll have to be 7. Which we could have resolved anyway. Okay, I guess it's just for decoration. We've got 1 to finish and a leisurely solve of just shy of 22 minutes. I'll take that. I had a lot of fun solving that, and importantly, it was a very well put together puzzle with a cool new novel technique. 2158. I hope you enjoyed wobbling and whispering. Well, I haven't done too much whispering to you, and I'm sure you'd all be wobbling if I did. So, yeah, it was a really neat puzzle. I think this was the correct place to start. Then I think those being restricted was really neat. I don't think we missed anything in the route of the solving, which would have saved heaps of time. Maybe the observation about the adjacent numbers I thought would be more helpful than it was. And it was mildly helpful later on, but nothing immediately. I think you could probably have done without it even. But yeah, lovely. Well, thanks for listening. And let me know how you got on. And I'll see you all very soon. Bye-bye.